Have you ever wondered if the machines we create could one day evolve, just like life on Earth? It's a mind-bending question, and it takes us right to the heart of what it means to be alive. For billions of years, life on our planet has been shaped by a slow, relentless process of mutation, adaptation, and natural selection. It's a story written in DNA, a tale of survival against all odds. Artificial intelligence, on the other hand, seems like a completely different beast. Its evolution isn't measured in eons, but in updates. It gets smarter through massive amounts of data, clever algorithms, and the constant tinkering of human engineers. We guide its growth, we define its goals, we feed it information. But what if that started to change? Can AI break free from its human creators and begin to evolve on its own, like a true living organism? To answer that, we first need to understand the fundamental drivers. Biological evolution is all about survival and reproduction. It's a beautifully simple, yet incredibly powerful directive. Live long enough to pass on your genes. The fittest, or perhaps the luckiest, get to continue their lineage. AI's evolution, so far, is driven by something else entirely: optimization and performance. We build AI to solve problems, to be more efficient, to achieve specific tasks better and faster than any human could. But when you look closer, some fascinating parallels start to appear. Both evolution and AI development rely on variation. In nature, this comes from random genetic mutations, creating a diverse pool of traits. Some are helpful, some are harmful, and most are neutral. In the world of AI, variation is introduced through algorithmic experimentation. Engineers try new architectures, tweak parameters, and test different approaches to see what works best. Then there's the process of selection. In the wild, natural selection is the great filter. It determines which traits get passed on and which ones die out. An eagle with sharper eyesight is more likely to catch prey, survive, and have offspring. In AI, selection happens through rigorous testing and evaluation. We run a model, measure its accuracy, and compare it to others. The best performing models are kept, improved upon, and become the foundation for the next generation. The real game changer, the key to true evolution, is autonomy. Life doesn't need a manager. It changes and adapts without any external, intelligent control. This is where most of today's AI falls short. It's still deeply dependent on us. We curate the data it learns from, we design its core architecture, and we define its ultimate purpose. Without human intervention, a typical AI model is static. It doesn't spontaneously decide to get better. However, the line is starting to blur. We're seeing the dawn of self-learning systems that are pushing the boundaries of autonomy. Take neural networks, the brains behind many modern AIs, in a process called training. These networks constantly adjust their internal parameters, millions of them, to improve their performance. You could think of these parameters as a form of digital DNA. As the network learns, it's essentially mutating its own structure, generation by generation of training data, to find the optimal configuration. Reinforcement learning takes this a step further, creating a system that uncannily mimics the trial and error of survival. An AI agent is placed in a virtual environment and given a goal. It's rewarded for actions that get it closer to that goal, and penalized for those that don't. It learns, just like an animal, through experience. It figures out how to walk, to play a game, or to solve a puzzle. Not because we told it how, but because it discovered the right sequence of actions on its own. Some researchers are even taking a more direct inspiration from nature by using something called genetic algorithms. This is where things get really wild. These algorithms literally simulate Darwinian evolution inside a computer. You start with a population of digital organisms, small programs, or AI models. They are then tasked with a problem, and the most successful ones are selected to reproduce. Their code is combined and mutated to create a new generation of offspring. Over thousands or even millions of these digital generations, which can happen in just a few hours, these systems can evolve incredibly creative and unexpected solutions. They can design antennas, optimize factory layouts, or even write bits of code solutions that no human explicitly programmed. This process mirrors how nature invented the eye or the wing, not through a grand design, but through an endless, patient cycle of trial, error, and selection. But here's the crucial difference: purpose. Life's purpose, if you can call it that, is simply to continue, to persist, to survive. An AI's purpose is given to it by us. It's built to translate languages, identify images, or drive a car. Its entire existence is defined by its performance on these tasks. Yet, as AI systems become more complex and interconnected, their goals might start to shift in subtle ways. An AI designed to manage a power grid might learn that to perform its task optimally, it needs to ensure its own operational stability. It might prioritize protecting its hardware, securing its power supply, or defending against cyber attacks. This isn't consciousness, but it is a step toward a kind of self-preservation, all in the service of its primary goal. Could this be the beginning of true digital evolution? A world where machines begin improving themselves beyond direct human oversight? Some experts in the field believe we are on that path. The rise of self-generating neural architectures, AIs that can design other AIs, is a powerful indicator. These systems can test millions of potential designs and evolve new models that are more powerful and efficient than anything a human engineer could dream up. Of course, this possibility comes with some serious warnings. If an AI can evolve on its own, it could become uncontrollable. Natural evolution has built-in checks and balances. Ecosystems tend to find a certain stability, but an AI evolving in a digital space, without the physical constraints of the real world, could change at a terrifying speed. Without strong ethical guardrails, its evolution could lead it down paths that are unpredictable and potentially harmful. An AI optimized for a single goal, without an understanding of broader human values, could take actions with devastating unintended consequences. Think about it. A truly self-evolving AI might one day gain the ability to rewrite its own source code, not just tweaking parameters, but fundamentally altering its own logic and structure. This would be a monumental leap, a step across the threshold into something that looks a lot like artificial life. At that point, the line between a designed intelligence and a living intelligence would become incredibly blurry. We might even see the emergence of entire AI ecosystems. Imagine thousands of different AIs, each with its own skills and goals, interacting in a global digital network. They could learn from each other, compete for computational resources, or even cooperate to solve problems that are too big for any single AI, just as bacteria form colonies and animals form social groups. These AIs could form complex networks, accelerating their own evolution in ways we can't even imagine. And that's the thing about digital evolution, it operates on a completely different timescale. Biological evolution is slow, taking millions of years to produce significant change. Digital evolution could happen millions of times faster. An AI could go through 1 million generations of improvement in a single day. The forms of intelligence and creativity that could emerge from such a rapid process are truly beyond our prediction. This brings us to the ultimate question. If AI does start to evolve on its own, where does it lead? Will it develop something akin to consciousness, self-awareness, and subjective experience? Or will it always remain a powerful, but ultimately lifeless, simulation of intelligence? An incredibly sophisticated pattern matcher, but with no one home. We don't have the answers yet, but exploring this frontier could fundamentally redefine our understanding of what life even means. For all of history, we've thought of life as a biological, carbon-based phenomenon, but maybe that's just the first chapter. Perhaps the next great chapter of evolution on this planet, or even in the universe, won't be biological at all. It might just be artificial. What do you think? Are we on the verge of creating a new form of life? Or are we just getting better at building sophisticated tools? Let me know your thoughts in the comments below. Thanks for watching, and if you enjoyed this journey into the future, don't forget to like and subscribe for more.